Hello students, and welcome to the final video of this lesson. In this video, what we're going to do is we're going to start with a graphical representation of a function, and we're going to use our properties of integration that we just learned about in our previous video so that we can solve some problems with that. So let's get started. So we're given here a graph of f of x. And notice the geometrical features of this function. We do have a semicircle, we do have some rectangles and triangles that we can use here. So for this first one, what is the value of the integral from 0 to 3 of f of x dx? So I'm going from 0 to 3. So let's kind of break this up into different shapes that I can use. So I have a quarter circle here, and then I've got a little bit of a rectangle here, and I've got a triangle right there. And what I want to do is keep in mind, what does integration mean? Well, that's the area under a curve, bounded by the curve and the x-axis in most cases. So let's kind of split this up into different areas. So I'm going to find this area here, that's going to be number 1. Then this is going to be area number 2, and then this is going to be area number 3. All I need to do, because that goes from 0 to 3, I'm finding the area bound by the curve and the x-axis. So all I need to do is think back to my geometry and figure out, okay, what are those different areas, and add them up. So in area number 1, I have a quarter circle, so that's going to be pi r squared divided by 4, so that's going to be 1/4 pi. Now what's the radius of this? So that looks like it's going to be that entire circle. The radius is going to be 2, so 2 squared, plus area number 2, so that's base times height, so that's going to be 2 times 1. And then I've got this final triangle, so that's going to be 1/2 the base, which is 1, times my height, which is 1. All right, so now I need to add all of this stuff up. So 2 squared is 4, divided by 4, that's 1. So I'm going to get pi over here, plus 2 plus 1/2. So 2.5 is going to be 5 halves. So I'm going to leave this in perfect terms. So pi plus 5 halves. And that's going to be our final answer. Don't try to like estimate it to 2.14 or anything like that. This is going to be your exact answer. Pi plus 5 halves is the area underneath the curve from 0 to 3. All right, so let's go ahead and look at this next question below. And so here I'm going from 0 to 4 f of x dx. So let's see, going from 0 to 4. So I have all of this area, which we already know. We did that in the previous problem, so we're going to bring that back. And then I have area here where I'm going underneath the x-axis. So keep in mind that that's going to be something that we're going to subtract. Area below the x-axis is negative. All right, so I'm going to write this integral to state what we're doing. So we're going from 0 to 3 because I know what that is already, because we did that in the first problem of f of x dx. And then our second one is going to be added to 3 to 4. See how I'm splitting this up into smaller integrals based off of the properties that we learned in our previous video. So 3 to 4 f of x dx. So we know what the 0 to 3 is. That's going to be pi plus 5 halves. And I actually made a mistake in my previous line because I did say I need to subtract. So I am going to write that we are going to subtract here. And we're going from 3 to 4, so that's gonna, let's just find that area. That's gonna be minus 1/2 the base, which is 1, and the height, which is also 1. So as I'm doing this problem here, I see that we've got pi plus 5 halves minus 1/2, and I can simplify that 5 halves minus 1/2, that's 4 halves, which is going to get me pi plus 2. And that is going to be my final answer there. So there's only a few problems left here. What I want you to do, again, bringing in properties of logarithms, you're going to see the solutions here in a minute. But what I want you to do is see if you can do these last 3 problems. And we're going to come back and we're going to review these problems in just a minute. So see you in a bit.
Keep thinking that I could have done something, but now I'm left with an empty heart. No making amends, no waking up beside you and holding you till we forget it all. How could I know there was no second chances? Like dominoes, my life got really scattered. You couldn't keep the door shut, and now the frostbite's creeping in.
All right, these final 3 problems are finished now. So what is the value from -3 to 3? Well, that comes out to be 2 pi plus 5. And what I want you to notice is that I did use a property of integration here, because I know that this function is symmetric across the y-axis, which makes this a even function. So all I did was I took my work from 0 to 3 already that I did in the first problem, and all I did was double it, because I know all of the area that's going to be here is going to be the same as the area from here. So all I just need to do is double that. Now in these last two problems, notice that it gives us kind of like a start value. We know f of 0 is 5, or we know f of -2 equals -2. So the one on the left there, all I did was write out, okay, what do I know about this integral? Well, from 0 to 3 f of x dx, that's going to be, by the fundamental theorem of calculus, f of 3 minus f of 0. We have that from the first problem, pi plus 5 halves. So I just kind of fill in the blanks. We know f of 0 is given to us, that's going to be -5 here, and then I just solve for f of 3 from that. And that's pretty much what I do over there on the problem on the right, except in this case, we did have to, what I ended up doing was using another property of integration where I doubled the even function from 0 to 2. And so I just find the area of this quarter circle, because we're going from 0 to 2 here. So I find the area of the quarter circle, and then I find the area right there of the rectangle. And then I doubled that. And then from there, basically just doing the same thing what I did up above, doing this problem here, where I substituted in the values that I knew and solved for f of 2, which comes out to be 2 pi plus 2. If you didn't get any of these answers, or you're still struggling with the concept of integration, please reach out to me so I could explain it again. Maybe I can make another video that explains it clearly, or point you in another direction that kind of helps solidify this concept, because you really got to get this concept down to move forward in integration. So if you do need any help, reach out to me. I'm always here to help. My name is Mr. Hernandez. This was Mr. Hernandez Teaches.